Imagine for a second that robots could help people learn to walk again after something life-changing, like a stroke. Well, that world is already here, and Thailand has gone all in on this incredible technology. But this isn't just some feel-good story about medical marvels. Nope, this is really an economic mystery.
Because that's the price tag, 420 million baht. That's right, that is the total amount of money Thailand has poured into getting these super advanced rehab robots into hospitals all across the country. It's a huge bet on the future of healthcare.
And that brings us to the big question, the real heart of this whole explainer. When you spend that much money, you have to ask, is it actually working? Is this amazing tech getting to the people who need it most? And, maybe just as important, can the system actually afford it? All right, let's dig in.
So first things first, what exactly is this technology at the center of our multi-million baht story? Let's break it down real quick. It's called Robot-Assisted Gait Training, or RAGT for short. Basically, these are incredibly sophisticated machines that physically guide a patient's legs over and over through the natural motion of walking. It helps the brain and the body literally rewire themselves. Now, there are three main types you'll see.
The first one is the stationary exoskeletal type. Just picture this. A patient is safely supported in a harness hovering over a treadmill, and these big robotic legs are strapped to their own legs, doing the work. It's a really controlled, very repetitive way to retrain that walking muscle memory. Second, you have what are called end effector systems. Now, these are a bit different. Instead of moving the whole leg, they focus just on the feet, guiding them on these moving plates. This actually lets the hip and knee move more naturally. And what's really interesting is that this is the most common type of robot you'll find in Thailand. And finally, we get to the really futuristic-looking ones, the overground, or wearable, exoskeletons. These are basically portable robotic suits. They let patients get off the treadmill completely and practice walking in a more real-world setting, like just down a normal hallway.
Okay, so now we get the tech. But this is where our mystery really starts to unfold. Because it turns out, where you put these multi-million baht robots, well, it makes all the difference in the world. This is a tale of two very, very different healthcare systems, public versus private.
So across the whole country, there are 56 of these advanced robotic units. And when you look at the breakdown, it seems pretty fair, right? A little over half, 57%, are in public hospitals, and the other 43% are in private ones. On the surface, that looks pretty balanced. But that is not the whole story. Not even close.
And boom, here's our first major clue. In private hospitals, these expensive robots are being used almost 69% of the time they're available. But in public hospitals, that number just plummets to about 45%. That isn't a small gap. That is a massive difference in how often these machines are actually helping people.
You might be thinking, okay, a 23-point difference, what's the big deal? Well, when you're talking about equipment this expensive, that gap has huge, and I mean huge, financial consequences. Let's see how this one number creates a crisis.
Okay, this slide says it all. This is the brutal economic reality. For a public hospital, just to break even, just to cover its costs, it needs to have that robot running over 81% of the time. But remember, they're only hitting 45%. They are losing a ton of money. Meanwhile, private hospitals, they only need to hit about 11% usage to be in the black, and they're crushing that at nearly 69%. They're not just breaking even, they are highly profitable.
And here it is, the stark conclusion from the research. Think about this for a second. Fewer than 1 out of every 4 public hospitals that have this amazing technology can actually make it work financially. The rest, they're losing money on it every single day.
But just when the story seems really bleak, especially for the public hospitals, the data reveals this amazing, kind of surprising twist. It turns out a big part of the solution might not come from some big international company, but from right there at home in Thailand.
So if you look at the different brands of these robots, one just jumps right off the page. The system with the biggest market share is called SensibleSTEP, and it's made in Thailand. But check out its economic performance. It delivers an average return on investment of almost 169%. That absolutely blows its international competitors out of the water. So what does a crazy high ROI like that actually mean in the real world? Well, it's all about how fast you can pay the machine off. For one of the big international systems, it takes about 3 years on average. But the homegrown SensibleSTEP Pro, it pays for itself in just 1.8 years. That's a massive economic advantage.
Okay, so we have all our clues now, right? We've got this huge usage gap between public and private hospitals.
And we've got this amazing, high-performing local technology. So now, let's put all the pieces together and solve this puzzle. Why does this huge economic gap even exist?
Well, for public hospitals, it's kind of like they're fighting with one hand tied behind their back. The government only pays them 420 baht for a session, which is incredibly low. Plus, they're stuck with normal business hours, they often don't have enough trained staff to run the machines, and they have trouble scheduling patients efficiently. All that adds up to a lot of wasted, expensive downtime.
Now, on the flip side, private hospitals are playing a completely different game. They can charge premium prices, on average 2,100 baht a session. That's 5 times the public rate. They can stay open longer, they have staff dedicated just to these machines, and they're really good at marketing to make sure there's always a line of patients waiting.
Okay, so we get the problem. We see why it's happening. But just pointing out the problem isn't enough. The great thing is, the research doesn't just stop there. It actually gives a clear, totally actionable plan to make this massive investment finally work for everyone. Here's the 4-step roadmap they propose. First, and this is the big one, they have to fix the reimbursement rates to reflect what this therapy actually costs. Second, help public hospitals use what they have better, extend their hours, get smarter with scheduling. Third, create regional hub centers so one machine can serve a much wider area. And fourth, make it a priority to use the domestic tech, like SensibleSTEP, to get a much better return on investment.
And the goal of all of this isn't some vague idea, it's a hard number. The research shows that if they can get every system, public and private, to be running at least 60% of the time, that's the magic number. That's the threshold where the whole program becomes economically sustainable for the long haul.
So at the end of the day, what's the big lesson here? It's that it's not enough to just buy the coolest, most futuristic technology. That's just step one. To really make it work, you have to find that perfect balance between the amazing things it can do for patients and the cold, hard reality of the economics. Which really leaves us with one final thought to chew on. The engineering that goes into these robots is absolutely brilliant. They can learn, they can adapt, they can help a human brain relearn how to walk. So the question for us is, can we be that smart? Can we learn how to build a system that uses this technology not just effectively, but wisely and fairly so that everyone who needs it has a real chance to walk again?